In story problems about real-life situations, we can put those into linear equations. The y-intercept is often the initial value, or as I mentioned today, the constant term, and the slope is the rate of change. So in this problem, the temperature at Earth's surface averages about 20 degrees Celsius. In the crust below the surface, the temperature rises by about 25 degrees Celsius per kilometer of depth. So if I simply just look at that for a constant term, I see my constant term is 20 degrees Celsius, which we said was going to be our y-intercept. I put it in the slope-intercept form as my constant term. And it says rises by about 25 degrees Celsius per kilometer. So when I see the word per, I know that's a rate. And as I mentioned above, the rate of change is usually your slope. So I put that in as my coefficient to x. Going back to the story problem, it says write an equation that approximates the temperature below Earth's surface. So that's what we want it to equal to. Again, putting in slope-intercept, that would be my y. I'll solve for that. As a function of depth, so that's why it's going to be a linear equation, because it says as a function of depth. We have our coefficient in red that we spoke about already. We're going to leave x as x because there could be many different x and y values. And then I place my constant term as my y-intercept, or as b in that equation. Now we are going to talk about some special kinds of lines, parallel lines. As you see on the grid, we have a set of parallel lines. They are always the same distance apart from each other. We're also going to learn a new characteristic, that parallel lines have the same slope. We can show that they have the same slope by putting a point on the y-intercept, and then we can go to the next point that we see that is on a good part of the grid. So I'm going to go 1, 2, rise 2, and over 1, and that is at an intersecting point. So the slope of this line here is going to be a slope of 2 over 1, or 2. I can do the same thing to the other line. I'm going to identify the y-intercept, and again for the slope I'm going to go up 2 and over 1 to prove that they have the same slope. So parallel lines are going to have the same slope, however notice that they have different y-intercepts. If they didn't have different y-intercepts, they would be the same line. The other one you might remember is perpendicular lines. We talked about this way back in 6th grade. That means that they make an intersecting point that has exact right angles. We're going to learn how that has to deal with slope here. So again, I'm going to go to the y-intercept of this line. We'll do first. That is at 0, 1. And if I go to the next part where it crosses the grid perfectly, I went up 2 and over 1. That was a point that I could identify. So 2 over 1 would give me the slope of 2 for this line here. Now we're going to go to the line that's perpendicular to it, the intersecting that makes the right angles. I'm going to find where it crosses the y-axis, which is going to be right here, I believe, is where we're supposed to see that. And that's at 0, 0. And then I'm going to go to another point, and I'm going to go to this point. To go to this point, I'd go down 1 and over 2, giving me rise -1, run 2, -1/2. Remember, we can also do that a different way. I could go back to my y-intercept point, and I could actually rise only 1 positive, but because it's a -1/2, I need to run 2, so 1, 2, and that still shows you that this line here has a slope of a -1/2. When you're looking at those two slopes, you should notice that they are opposite reciprocals of each other. So, or negative reciprocals of them, you could say as well. If this was a fraction, it would be 2 over 1. Reciprocal, you flip it. So this one is 1 over 2. And then we said the negative reciprocal of it is -1/2. If we were looking at this slope first, we would flip it for the other slope, so 2 over 1, and then negative would give me a positive 2 over 1. Once again, their slopes are negative reciprocals of each other. Now, how does that come into play with our equations of our lines? So it says find the slope of a line that has the given relationship to the line with the equation. And they give us an equation, much like your homework for today, the stuff we started in class today, 4x plus 3y equals negative 18. Now, to do anything with this, I need to first put it in y-intercept form, which I thought I had. Oh, I know where it is. Pull this out here. There we go. Get the y on the left side of the equal sign. To do that, I subtracted 4x from both sides. It canceled it out here, and it changed it to a negative 4x on this side of the equal sign. And we still have a negative 18. Then I don't want to know how many 3y's are, so I divide everything by 3, giving me 3y divided by 3 gave me my y. Negative 4 divided by 3 leaves it as a fraction for my slope coefficient, so that's negative 4 over 3x. And then negative 18 divided by 3 gives me negative 6. Now that I have it in slope-intercept form, even without seeing a graph, I can tell you the slope of the parallel line and the perpendicular. Parallel, again, has the same slope, so we should see a negative 4/3 there. Perpendicular is the one that has the opposite or the negative reciprocal. So it would be 3/4 when I flip it, and the opposite sign, or the negative would be a positive 3/4. Let's see those on the graph. I have the equation written in the slope-intercept form. I'm going to go to my b for beginning. My y-intercept would be at negative 6. My slope is going to be a negative 4, 3. I could go down 4, 1, 2, 3, 4. Then I'm going to go run positive 1, 2, 3. Or I could have also gone up 4, 1, 2, 3, 4, and over to the left 3, and that point would have been here. When I connect my points, I'm going to have my equation of my line. Get that a little bit. Won't let me steer it too well here. There we go. And there is graphing that line as you did in today's assignment. And let's go through some of the rules again. So two non-vertical parallel lines have the same slope. Find the slope of a line that has the given relationship to this equation. So what did we do first? We went ahead and put it in y-intercept form, and then we could look at the slope, and it needs to have the same slope. Reviewing the perpendicular one, again, has to be in slope-intercept form first. Then we look at what our slope is, and if it's a perpendicular line, it's going to be a negative reciprocal. So flip it and give it the opposite sign. And that is the end of the second part of 8.5.